more squeeze theorem example. So the first one is limit as x approaches to 0. We have x squared times cosine 1 of x. So if you plug in a 0 to the cosine, you have 1 divided by 0. So this one, looking at the graph of cosine 1 over x, what do you see? You see that the cosine 1 over x is between 1 and -1. So the line, the curve exists between y equals to 1 and y equals to -1, right? So that is how we start. We say that cosine 1 over x, this is between 1 and -1, and then we build on top of that by multiplying each side by x squared. So we have negative x squared less than or equal to x squared times cosine 1 over x, and then x squared times 1. So the limit of x squared and negative x squared is easy to do, right? So as x approaches to 0, x approaches to 0, we have a 0 square. So this is a 0 less than or equal to, this is a 0 as well, since the function that we are looking for is sandwiched between 0. So this one must be a 0. So that carries over here. That makes the limit equals to 0 by squeeze theorem. So by squeeze theorem. If you change the cosine 1 over x to sine 1 over x, you will get the same conclusion. You can try this yourself. The next one we have cosine square x in the denominator. All right, cosine square x. In the previous video, I already discussed what to do when you see a sine square x or cosine square x, but this time the cosine square x is in the denominator. So take a look. The cosine square, first of all, for cosine square, do we still have curve below the x-axis? The answer is no. So if you just graph cosine, just cosine x, then that is the dashed line. Cosine is between 1 and -1, but when you square the cosine, all the negative parts are gone. So the curve is now between 0 and 1. So that's why when we start with this, we write cosine x is between -1 and 1. No question with that. But once you square this, then you have to write between 1 and 0, because this is between 1 and 0. All right, between 1 and 0. It's bouncing between y equals to 1 and y equals to 0. Oops, 0. Y equals to 1 and y equals to 0. So that's, you're not just taking the square of -1 is 0. That is not true. We are saying that is a 0 because the curve is between 0 and 1. All right. Okay, moving on, we build on top of that, and then we add a 2x to it, right? So we have a 2x less than or equal to 2x plus cosine square x less than or equal to 2x plus 1. And then we have to take 5, divide each side, then there is one big thing to change, and this is why I put the cosine square in the denominator. So we have 5 divided by 2x, and then 5 divided by 2x plus cosine square x, and then 5 divided by 2x plus 1. So do we need to change the sign? Do we need to? So to answer these questions, how about this? So let's say we have 2 less than or equal to 5 less than or equal to 10. When we take 1 divide each number, do we change the sign? Do we change the direction of the inequality sign? 1/2, 1/5, 1/10. Which one is the biggest? The 1/2 is the biggest, right? The 1/10 is the smallest. So that's why we have to change the sign. So let's put this in big using highlighter. We have to change the sign. All right, so now as x approaches to infinity, so this is easy to evaluate. As x approaches to infinity, what do we have? We have 5 divided by infinity, which is a 0 greater than or equal to, this is a greater than or equal to 0. So the only case to squeeze a number in here is a 0. 0 is between these two 0. So as a result, this is equals to 0. So this carry this 0 to the top. So carry this 0 to the top. So that is equals to 0 by squeeze theorem. All right. So squeeze theorem, when you see squeeze theorem, they often put a sine, cosine, sine square, or cosine square in the problem. So for the orange problem, if you change the cosine square to a sine square, you will get the same conclusion. So what if there is no trigonometric function? So let's take a look at this example. So what if I have limit as x approaches to infinity, I have x divided by the square root of 4x to the third. 4x to the third power, and then plus 2. So this time there is no sine or cosine for you to set up the inequality. So what do we do? So here is what we do. I am going to put this given function right in the middle, and then 4x to the third plus 2. So when x is infinity, when x becomes so big in the denominator, the 2 doesn't really matter, right? When x is so big, adding the 2, not adding the 2 won't change anything. But if you take away the 2, do we agree that the denominator just got smaller if you take away the 2? Right? We take away the 2, the denominator just got smaller, so that's why we can put x divided by the square root of 4x to the third. And then this one, the smallest, I will just put a 0. I will just put a 0. So as x approaches to infinity, the 0 stays as a 0. What happens when x approaches to infinity? So when x approaches to infinity, here is what we can do. We can have a x. The square root of 4 is equals to 2, right? And then the square root of x to the third, we can break it down to x squared times x. So we can take one x out, and then this stays inside. And then we get rid of the x. So that is equals to 1 divided by 2 root x. So as long as x goes to infinity, then we will have a 0. So when x goes to infinity, then we have a 0. So this one is just saying 0 less than or equal to. So this is another 0. So that means this one has to be a 0. So this is equals to 0 by squeeze theorem. Alright, that is the end of this video. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will catch you all in the next one. Signing out.